In Module 2, we'll have a look at Azure Batch Processing Reference Architectures. But before we do that, Chris, let's spend a minute and talk about the MCT presentation guidance.
Yeah, so within the PowerPoint slides, we have a hidden slide right at the top of the slide, which looks like this. This slide is not for anyone else's benefit. It's for your eyes only as Microsoft Certified Trainers or as your technical trainers.
Yep.
So what the idea behind this is that we're using it as a brief for this particular module. So it tells you roughly how long the presentation should be, how long the lab should be, and how long the lab review should be. So you'll notice in this course that the lab and the lab review takes way more time than the actual presentation itself.
That makes sense.
Which is reflective of the kind of group dynamics that you want with this. You've got the audience who it's for, and then we outline the purpose, right? So the student should clearly understand the definition and the purpose of a Lambda architecture, and the student is exposed to example architectures for batch processing of data. Okay?
Okay.
3 motivations that I think about when I'm delivering, right? What do I want the students to think while they're doing this module? The students should understand the key data storage technologies that are used in batch processing. They should understand what technologies can be used to automate that batch processing. The students should be clear of the support they may have to provide in supporting an AI solution with bots.
Understand some of these concepts.
Exactly.
I kind of see an opportunity there to maybe put that in a data and AI fundamentals, for example.
That'd be a good idea. If we can do that, that'd be awesome. The other thing is I think about how they feel as well. It's really important to me that I try and empathize with my students. So they should feel that they can at least relate one of the architectures as a potential architecture for their organization, right? I'm not saying they'll use it wholeheartedly, but I'm kind of hoping...
They're not solution architects, but they know how to do a design given those requirements.
Exactly.
To then bring that back to one of the architects and say, this is what we think we could do from a... It's more like a architect advisory role almost.
Yeah, almost, And the students should feel that these architectures are similar to what they've defined at work in the past. They're just using different technologies, you know, and platforms to do it in. Finally, what's the action you want them to do? Well, the students should understand the technologies that are part of the architectures presented, and they should be able to explore opportunities of batch processing Lambda architectures for their organizations. That's the action. Now, we have one of these for every single module.
Makes sense.
With this, coupled with the lab direction that you have, that will help you in guiding the overall module.
Okay. So let's drill down to this module then.
Yeah, so let's have a look at the lesson objectives, of which there are 4. First of all, we're going to define what Lambda architectures are, but look at it from the prism of batch mode operations. Then we'll provide an example of 3 architectures. Enterprise Business Intelligence Solution, an automated enterprise business intelligence solution, and architecting an enterprise conversational bot. Heads up here, this might look completely overwhelming. That's fine, right? You're not expected to know every single bit of this particular architecture. What we want to do in this final one is pull out the salient parts to the data engineer.
Conceptual designs.
Exactly, because the rest of it is being dealt with by either a data scientist or an AI engineer. Okay? So we've only literally got 4 slides here. You may have to spend some time on this slide to begin with, right? You may potentially have some students that don't know what a Lambda architecture is. So talk about Lambda architectures from a batch layer, which is using to pre-compute results on large volumes of data using distributed data systems, and the serving layer. And that acts as the storage output for either the batch or the speed layer. Now, bear in mind, we're going to do the speed layer in the next module, so don't focus too much on speed layer at the moment. It's only there for completeness, really, because if you don't have that there, someone who knows Lambda architecture is going to go, that isn't a Lambda architecture because you haven't got the speed layer. So from this, what you're going to go through is, if you've got new data, it can either be processed at a batch layer, pre-computed, and then served up, where queries can call that. and focus on that top layer there, okay?
Yep, makes sense.
Now, if your group has done DP-200, ask them, can you think of any example technologies that would work at the batch layer?
And then they should bring a solution design, little architecture.
That's the end game that we're trying to get to, right? But you're planting those seeds as you go through. You've got 4 slides, right, here. Now, the way that we do this is once the students are comfortable, we deliberately picked an architecture that we felt would resonate with on-premises SQL Server professionals.
You have an example on that?
Next slide.
Okay.
So what we did here is we talked of an example of an enterprise business intelligence architecture.
Yeah.
So maybe your data source is an on-premises SQL Server.
Yeah. Okay.
You ingest data into that, into some kind of staging area. Let's say a storage blob, right?
Arguably, you would say, why would you not pre-stage it directly into your warehouse?
You could do, but then you can get into architecture discussion points around performance and availability, which is what you would have done in the data warehousing course in the past, right? So that this you want those questions to come up because it becomes more of a discussion. As a trainer, you're using these salient points to shape a discussion with the group. I could argue that another question could come through, why am I not using data lake storage instead of blob storage? That is a valid point, you know, and you can you can literally have discussion points as, well, storage blob is cheaper.
And I would be like, where is your Azure Data Factory?
Exactly.
How are how you bring them to the warehouse? Do you have Polybase there?
Well, you want to keep it in the context of where you're at, because you could argue that, you know, the data storage, you just want to focus on the data platforms that are batch storage there. Analysis, we used one example of Azure analysis services there. And then we called in the interaction with Azure Active Directory. That was put in there deliberately to keep reminding you that you have to take a holistic point of view of this, right? You can't just look at it from a data, which is why that's been done. And then, of course, visualization being done through Power BI. Now, you raised a really, really good point about Data Factory, right? And I deliberately held back because that's the next slide.
There we go.
There's your Data Factory, right? Because this is fundamentally the same architecture with Data Factory wrapped around the ingestion and the storage as it moves data from storage blob into Azure SQL Data Warehouse. So again, if you think about Module 1 when we talk about architecting great Azure architectures, here we're accounting with Data Factory for efficiency and operations because we're using Data Factory to facilitate automation in the data movement there.
And then I could click down and go to things like streaming data and stream analytics. Potentially could come into play on that external data.
Yeah, but what we do is we do that for Module 3 because streaming analytics is real time. But it's a difficult course because we could go into so much more, but what we've done is not put it in there and saved it for the lab, and we've put it in the instructor notes for the labs. So they've got something to work with, right? At this stage, as long as they kind of understand that, well, there's source, there's ingestion, there's storage, there's analysis, there's visualization. This is an example of one, but this is where the case study becomes really important, right? Because you're going to use the case study with that very specific case to come up with an architecture for that.
Okay. Whoa.
Glad you did that.
It's a little overwhelming.
Absolutely glad you did that. It is meant to be overwhelming.
That is so overwhelming.
This is a real architecture that myself and Buckwoody and Anna worked on when we were in AI engineering, right? But the is we didn't work on all of it. Okay? It's still overwhelming, but this is why did we put this in? A, there are more workloads that are using artificial intelligence. In this case, we picked a bot, right? B, it's again further cementing the point that when it comes to architectures, you have to take a holistic viewpoint. You can't look at it in isolation of data. And 3, we wanted to expose you to an architecture that has been done in the real world in AI, right? So where do we get involved? We get involved with the logging, and we get involved with the data and ETL. Now, let me first explore logging. By default, bots don't log conversations, right?
You got caching.
Exactly. Yeah. It's done in memory, basically. It's minimal, right? But that basically means that, you know, it basically means that privacy is being handled by not storing anything at all, okay? But you could choose to do bot logging, right? Now, the AI engineer would implement the bot logging within the bot itself. But it's likely that they're going to lean on you for a platform that stores that logging history.
Cosmos DB, blob storage.
Exactly. You've got a number of different objects.
Store it and then reuse it to retrain the model, optimize the bot.
Perfect. That's exactly it. So fundamentally, what we've got is Cosmos DB in this example that's literally holding the conversation and any feedbacks that have been given. So that's the actual insights from the user, right? And then Azure storage is offloading, if you will, copies of that, and logs of the bot activity that you can use through monitoring and reporting on the right. Now, as I say, you wouldn't deal with the bot logic in UX. You wouldn't deal with the cognitive cognition of the bot or the intelligence of it at all. But you might be expected to provision Cosmos DB and Azure Blob to facilitate that. And in this case, with the Blob, you'd inform the AI engineer, here's the shared access key to access that, and here's the Cosmos DB API that you can access as well. On the other side of the equation, we wanted to give a different perspective that's not just AI, but from a data ETL perspective, right? Now,
this was initially a little overwhelming. It's like, wow, where do I start? But now that you explain it, it totally makes sense.
So again, the AI engineer is responsible for adding the intelligence to the bot through Lewis or Q&A Maker or so forth. You'll notice that the red box does touch on the intelligence a little bit. Let me explain why. Azure Search. There is a possibility you may get asked to provision Azure Search. And for that reason, it's basically keeping an index of all the AI
and I kind of feel that might be leaning more towards AI engineering.
Could be, but I've just got to acknowledge that it's there. What you'll definitely deal with, though, is the data factory with the data ETL. And you will probably have to set that up to be able to collect the information that's generated by the intelligence of the bot and then perhaps store that as raw data or structured files. The ultimate message we are trying to convey with this slide is that the world is now moving to AI architectures. They're not necessarily done by an individual. They're done by a team. And what may look very overwhelming to you, actually, you're only doing a part of it. You're doing the parts in the red box, and AI engineers doing other bits. You may even get an Azure engineer or an infrastructure working on the identity and the access and the security.
Perfect.
Okay, so with this module, what you've done really is you've exposed the students to example architectures that we've done here at Microsoft, and this takes us very nicely on to review questions to make sure that you solidify that knowledge, and then we get on to the lab. And with this lab, the goal is using the case study, what you're going to do is look for the business and technical requirements, building up a Lambda architecture from a batch mode perspective.
Spot on.
And with that, you'll use the case study and this scenario, which drills down a little bit more, where you've been advised that a solution architecture should take a holistic view of the batch mode architecture against the business and technical requirements of that case study, and then you're going to draft that up ready to be presented to the group. Now, essentially, what you're working on here is roughly 45 to 50 minutes. That group works on the 3 objectives. thinking about enterprise BI solutions, automating that, and architecting enterprise grade in the context of that case study. Once they do that, you get them to review, show they're off their architectures, which is why there's 30 minutes in the reviews. From there, identify any differences. See that as a positive, right? Because maybe they've seen something that the other group hasn't. And then look at how does the holistic architecture of a batch mode processing look. Okay, and again, that's exploring the architectures. As a module review, you go through what you've just done, and then I provide pointer information to the Azure reference architecture side, because we've only shown you 3, right? But there's a lot more there, and you should be directing your students to it.
So I think this covers batch processing design. Next module,
real time.
Real time.
Yeah.
So let's go have a look at that as well.
Sure.